Welcome to Cosmic Wonders. Today, we're doing a deep dive straight into our cosmic neighborhood, the solar system. And when we say solar system, it's not just the sun and the main planets, right? What else are we talking about here?
Oh, absolutely. Think bigger.
Hmm.
It's a whole family. You've got the sun at the center, sure, but also dwarf planets like Ceres, Pluto, and then hundreds of moons orbiting different planets and even some asteroids, plus countless asteroids themselves and comets too, all held together by the sun's gravity.
Okay, so it's a busy place. And where does this whole system live? Like, what's our address in the Milky Way galaxy?
Right, our galactic address. We're inside the Milky Way, which is a barred spiral galaxy. Our little spot is in one of the minor arms called the Orion arm. It's kind of tucked between the bigger Sagittarius and Perseus arms.
So, not exactly downtown Milky Way, but we're definitely moving, aren't we? I heard it's like a blistering
You
pace.
heard right. The whole system, everything we just mentioned, is zooming around the galactic center. The speed is something like 515,000 miles per hour. It's pretty mind-boggling.
Wow. And that orbit takes how long?
About 230 million years to go around just once. We call that a cosmic year.
A cosmic year. I like that. And the name solar system itself, that obviously points to the sun, doesn't it?
Exactly. Solar actually comes from the Latin word solus,
Hmm.
which just means sun. So quite literally, it's the sun system.
Simple enough. Now, with all this stuff flying around, the really big question people ask is, are we alone? Is NASA or anyone finding clues?
That search is, well, it's one of the biggest drivers in space exploration. NASA and other agencies are actively looking for signs of life, biosignatures, not just way out on exoplanets, but potentially right here, you know, on moons within our own solar system, like maybe Europa or Enceladus, places with suspected subsurface oceans.
Fascinating. So the potential could be closer than we think.
Yeah.
Okay, let's rewind. How did all this form? Where did our solar system even come from?
It all started a very long time ago, about 4.6 billion years back, from a massive swirling cloud of gas and dust floating in space, an interstellar cloud. Something, maybe the shock wave from a nearby exploding star, a supernova, likely triggered its collapse.
A collapsing cloud, so it just sort of fell in on itself?
Pretty much. Gravity pulled it all together. And as it collapsed, it started spinning faster and flattened out like pizza dough into a huge disk. We call that the solar nebula. And most of the material, the gas and dust, got pulled right into the very center.
Ah, and that central mass became the sun.
Precisely. The pressure and temperature at the core got so incredibly high that nuclear fusion ignited. Hydrogen atoms started fusing into helium. That reaction released a tremendous amount of energy, and bang, the sun was born. And get this, it contains something like over 99% of all the mass in the entire solar system.
99%. Wow, so what happened to the leftover 1% in that spinning disk? How did that become planets?
Well, out in the cooler parts of the disk, tiny bits of dust and ice started sticking together, clumping up. These clumps got bigger and bigger through collisions, forming planetesimals, sort of like planetary building blocks. Eventually, gravity pulled these together to form the planets, the dwarf planets, and the bigger moons we see.
Okay, that makes sense. But what about the asteroid belt between Mars and Jupiter? Is that like leftover construction material?
That's a great way to put it. Yeah, it's essentially rocky debris from that early period that never quite managed to form a full-fledged planet. Jupiter's immense gravity probably played a big role in preventing that from happening, stirring things up too much.
Right, Jupiter, the giant disruptor, and we have tons of moons. You mentioned hundreds.
Hundreds, yes. Orbiting planets, dwarf planets, even some asteroids have moons. It's quite amazing the variety out there. Though, interestingly, Mercury and Venus, the two closest planets to the sun, they don't have any moons at all.
No moons for them.
Brown.
And the overall layout, rocky planets close in, gas giants further out.
Yeah.
That wasn't random, was it?
Not at all. It's all down to temperature in that early solar nebula. It was incredibly hot near the young sun. Only materials with high melting points, like rock and metal, could condense and solidify there.
Which gives us Mercury, Venus, Earth, and Mars, the small rocky worlds.
Exactly. They're made of that tougher stuff that could handle the heat.
And then further out, where it was colder.
Out there, things like water ice, methane, ammonia volatiles could freeze and condense. These lighter materials were much more abundant, allowing huge cores to form, which then gravitationally captured massive amounts of hydrogen and helium gas, leading to the gas giants, Jupiter and Saturn, and the ice giants, Uranus and Neptune. It really shows how that early temperature gradient shaped everything.
It really paints a picture from a collapsing cloud to this intricate system we live in. Amazing.
It's a story billions of years in the making, and still unfolding in some ways.
Well, that about wraps up our exploration of the solar system's formation and structure for today. We hope this deep dive gave you some fascinating things to think about regarding our cosmic home.
Definitely plenty more wonders out there to explore.
Thank you for listening to this Cosmic Wonders episode.